functions because different pieces and parts of functions are within the same exact graph. The reason that there are splits or it's broken up is because of the domain and the restrictions set on the domain. So if you notice to the right, we're looking at 3 different functions. 2 of them are lines. Our blue is a line, our red is a line, and then our last one is a quadratic. All right, so it is split up by the domain. So there are cuts in the graph at -1 and +1, which is why our graphs change functions in between those 2 domains. So -1 and +1 is where we see a change in our functions. So our first line is x plus 2, which if I extended this line out, I would see it continues a slope of up 1 over 1, and it crosses through our y-intercept at 2, which is the line x plus 2. However, the domain says that we only want to see this line when x is less than 1. Well, here's our x is less than 1, so that line will only appear in that region. Our middle line is y is equal to 1. That is a horizontal line, and it's in between -1 and +1. So that would be our middle region between -1 and +1. You have a horizontal line of 1. Now we do know that lines extend off forever in both directions, but since we only want to restrict it to that domain, we only draw it in between -1 and +1 on the x-axis. Our last function is x squared, and it's in the domain of x's greater than 1. So that's why you can only see it on that portion. So the first thing we're going to do is evaluate functions. So that means plugging in a value of x. So if we look at our piecewise function, we're looking at 2 different lines, 2x plus 3, as well as x minus 5. It's really important to take note of what the domain is. So I have 2 different domains. I have a domain of x is less than 0, and the domain of x is greater than or equal to 0. So what I like to do is I like to go through and highlight or determine which value should go with my top line, which value should go with my bottom line. So I'm going to go through and check for all numbers that are less than 0. So -2 and -1/2 are both less than 0. And then I'm going to check for all numbers that are greater than or equal to 0, which includes 4, 1, 0, and 10. So when I'm solving, I know exactly which line I should be plugging into. So for number 1, we are evaluating our function at -2. Remember, that just means x is equal to -2. So I'm going to plug that into my top line. 2 times -2 plus 3, and use order of operations to get out -1. I'm going to skip to number 5 since it's using the same exact line. So this time I am looking to evaluate when x is -1/2. So I plug in 2 times -1/2 plus 3. I use order of operations to get a final answer of 2. My other numbers are going to fall within our second domain of x being greater than 0. So if I start with number 2, my x value is 4. So I plug in 4 minus 5 to get an output of -1. Number 3, I'm evaluating at f of 1. So my x value is 1. 1 subtract 5 is -4. Lastly, we're going to graph these by hand. When I'm graphing by hand, I want to look at the domain to start to see how I'm going to divide my graph into 3 different sections in this case, since I have 3 different lines, to match each line with its specific domain. So if I look at my domains, I am looking at the x values of -2 and +2. So I want to draw a line at those values. So I'm going to draw a line at -2 and a vertical line at +2 since it's dealing with x. And I've split my domain into 3 different parts. One where all values are less than -2. One where the values lie in between -2 and +2. And the last where the values are greater than 2. And then I'm just going to proceed in graphing like I do normally. So the first line that I'm graphing is y equals x plus 3. So I'm going to start at my y-intercept of 3, rise 1, run 1. I'm going to go in the opposite direction to make sure I go through all 3 domains. So since this line should only be in the x is less than -2 zone, I'm only going to connect my dots on that side. All other values get erased because that line does not exist in any other domain. Lastly, I do want to concentrate on this does not have an equal sign, so I'm going to place an open circle at the dotted line. My next graph, or next line, is y equals x minus 2. So I'm going to start off at -2, rise 1, run 1. This one's kind of nice because it needs to fall into my middle domain. So I'm just going to go from dashed line to dashed line, which I separated. I do need to be careful about my equal to sign. So at -2, I am filled in. At +2, I am open. And in our last line is y equals -2. So that means it has a slope of 0, so we're going to have a horizontal line. My y-intercept starts at -2, and then I know it's going to be on the right-hand side of my domain, so I'm just going to extend out in that direction and create my horizontal line. It is going to be a closed circle because of the equal to symbol, and I'm going to get rid of those yellow dots that I put